this is Kevin Benedict, Mobility Analyst, reporting live from San Diego today, where I have the privilege of being with the founder and CEO of ClickSoftware, Moshe BenBassat. Thank you for joining us today.
It's a pleasure, Kevin. How are you doing?
I'm doing very good. So you just flew in on a very long flight from Tel Aviv, didn't you?
Correct.
So I have a question. You have a very interesting background. And that background, from being a professor and teaching all kinds of things on artificial intelligence, and now you have just a phenomenal mobile applications company as well. Can you kind of walk us through that progression on how you studied artificial intelligence and how we see that represented in your mobile applications today?
Yeah, to me it's quite natural. Historically, I started in the late 70s, early 80s doing medical diagnostic systems at USC, essentially giving a physician a computer, let him input the symptoms, and then the computer will guide you as to which test to perform next, and eventually stop by telling you this is the more likely diagnosis. If you look into it, it requires quite sophisticated knowledge about the specific field of medicine that you are doing. I did it first for emergency and intensive care units, and then did the same for NASA, for space medicine. Also was involved in poisoning and arthritis. This was at UCLA. But all in all, it's always the same question. On the one hand, you have the knowledge base of a given domain, and on the other hand, you need inference engines, basically quite sophisticated algorithms to connect symptoms and diseases and probabilities and so forth. In fact, the MEDA system we did at USC was one of the early systems to utilize Bayesian inference networks that are quite popular today in artificial intelligence.
Wow, and then you have military experience as well, I understand.
That's correct. A few years later, I got involved in ballistic missile defense systems, where the challenge was how to recognize in real time threatening objects that are flying at you. Not too far from this was military situation assessment, first for the ground forces, then for the Army Research Institute, but later on also in the naval arenas. We did some exciting developments for intelligent situation assessment, and the word intelligent means the user no longer communicates with electronic sensors, but rather with real objects in the field. So rather than seeing all sorts of complex lines cross-cutting each other, they see objects, and when they click on the object, it tells them this ship is a threatening ship of this type, of this range, and so on and so forth. Along the way, we got involved with business applications. For instance, oil refineries in Spain and scheduling them. And
so Moshe, when we were talking before, you had talked about your work with ballistic missiles and oil refineries. Now, I also understand that you worked with the Israeli Air Force as well. Can you share with us some of that?
Yes. Every year, the Israeli Air Force needs to produce the annual plan. Which squadron performs which exercise at which location, with which auxiliary equipment, and the like. Without going into classified material, you can imagine that we are talking about tens of entities in each of the dimensions I mentioned, the number of units, the number of locations, the types of exercises, and very complex rules such as evacuation from F-15 should be exercised at least twice a year, with no more than 90 days between them, and so on and so forth. The scale of the problem is huge. The constraints are complex. And now to produce a plan that complies with all the constraints and the rules, this, even if it's not optimal, it's already quite complex one. We did it, and we won some nice awards for it, and this was our first entry into the, if you wish, the human-type scheduling, which later on led into ClickSoftware.
So you have artificial intelligence in the background. That's your background in your area of study. You have scheduling of very, very complex military forces here and their schedules. How do you see that represented in your mobile applications today, though, here in 2012?
Right. One of the beauties of artificial intelligence usages in business applications is in, first of all, train a computer in a complex problem the way your experts solve it, and then make this knowledge and inference engines for every people, every person in the organization, and this way everybody becomes an expert, what used to be known as expert systems. On top of it, there's some power that computer has that even if a human being can articulate a problem and can write down the process how to solve it, that actually practicing this algorithm could be just time consuming. Consider the service scheduling one that we use with ClickSoftware. A human being wrote these mathematical algorithms, but to practice them, you need quite powerful CPUs. You have thousands of technicians, thousands of jobs coming in, quite intense, and now you have to design the optimal allocation that considers also the travel route that each technician will do. So the way I view the artificial intelligence terms, it's, of course, silicon doesn't think. It's we mathematicians and domain business experts who think, put it into a software program, and later on it really practices for you your own service policy. So this is really what we did in the classic ClickSchedule product. And for instance, when you look into the ongoing continuous optimization that we do during the day, essentially they are represented by a group of software agents that continually fly over the service territory, and whenever they see that a problem might arise, they already get into the action automatically and try to fix it, or call the attention of the dispatcher that some fix needs to take place.
Can you give us an example, Moshe?
Sure. Picture a situation where technician X, technician 1, okay, is supposed to be for the next appointment at 2 o'clock. It's now 15 minutes before 2 o'clock, and the GPS shows that his car is still at the parking lot of the prior customer. Now the dispatcher looks at it and what's going to happen with the next customer. Today, it will wait until some response, some connection with the technician will take place in order to do some fixes. But quite frankly, if you put into the system a certain policy that says the following: if he is already running late, check what's happening with the other technicians. If some of them finished earlier, or possibly for some of them the customer did not wait at home and 2 hours became available, then you could proactively display to the dispatcher and say, look, this fellow is running late. You can switch him with Jim. How about doing that? Click yes if you wish to do.
So that's the connection between artificial intelligence and scheduling field service one.
That's correct.
So do you have a brand name for that solution?
Correct. We call them butlers.
Butlers,
Click butlers. And we really are taking this on to the end user, to the technician himself. So let's see what happens today in typical mobile solutions for service technicians. They come in the morning, they turn it on, they check in. Then they swipe into the day plan, and they realize, let's say, that the first job is at Bank of America, First Main Street. Now they need navigation instructions. Sometimes it would already be easy to copy and paste. Sometimes they would have to type it into the navigation. Everything takes time, as you know, swiping, looking, reading. Once they get to Bank of America, they park the car. Now they start looking, who is my contact person, and then they dial to the contact person to come and greet them at the reception desk.
Right.
Let's say that all this swiping and typing took 7-10 minutes. If you do 4 to 5 jobs per day, you are talking about 40 to 50 minutes a day that these technicians are swiping and typing.
Just to look up and just to know where he's supposed to go and what he's supposed to do and who he's supposed to call.
Very much correct.
Okay.
That's not how it's going to happen with Click butlers of ClickSoftware that are embedded in the mobility solutions.
Okay.
The moment that he logs in, my butler already knows what is planned for the day and the address. So instead of waiting for him to swipe, it will tell him, your first job is at Bank of America 1 Main Street. Would you like navigation instruction? Boom. You just save some swiping and typing.
Right.
Now, as you are driving, 10 minutes before you arrive, it will prompt you by saying your contact people at Bank of America is ABC. Click on the one you wish to call.
Right.
No dialing while typing, right? It's
Right,
also
right,
risky.
right.
And of course, you talk to him while you are still on the road. And as soon as you come out of the car, just getting ready to go to reception, this butler may also remind you, did you remember to take the spare parts with you that you need for this job? How does it know? That's artificial intelligence. You see, our solution, the mobility solution, is part of this big platform for service decision making. So it's the same business object. The same knowledge that is available for the scheduler is also available for the software of the technician. And whenever the butler can predict that you may need something or you might need something, it will proactively prompt you for it, and thereby first saving you time, but not less important, saving you mistakes. If you were to go now to the 15th floor to fix this printer, and now you realize that you forgot the spare part, it means going down 15 floors, going to the parking lot, getting the spare part, and another 5 or 7 minutes are gone by.
So, you know, it's so easy for companies to assume that a mobile app is a very lightweight, simple, forms-based app where they can open it up and see it, but they haven't thought often about the power that can be put behind a mobile app. And sounds like you guys have put a lot of thought behind that.
That's very much correct. Consumer level apps or lightweight apps could do parts of the job that we were talking about, but normally they do it in a segregated way, like the silo approach to building a solution. You can go today to iTunes and download apps for navigation, for scheduling, for job management, and so on and so forth. But then you will have to swipe back and forth, and you have to carry data literally by retyping or copying and pasting. This consumes time, and it's not tolerable in a business environment. Technicians expect a business software to know all of it. Like they will say, why do I have to type again the address? Don't you know that I'm going to Bank of America? It's on my job. It's written on my form.
It's on the service ticket.
Right. So the principle number one in business mobility applications is that data sharing and logic sharing, must exist between the apps. And that's what we insist on, or at least, the application that we deliver. The second principle, of course, is the fact that you've got to have connectivity with the back office system, at least when you are online, so that you can get the data.
Right.
Because otherwise, again, you will have to type and retype and retype.
So there's a lot more than just creating an interesting looking mobile app on the device.
Right. It goes beyond the nice user interfaces. And as you know, we do as well. In fact, we were one of the pioneers to start doing it on HTML5, and our mobility apps are device agnostics. They will run on any device, and that's the beauty of it. Now that we have the butlers, it will also be much more efficient to do it.
Great. Moshe, I want to thank you so much for sharing with us today.
You're welcome, Kevin. Thank you.